Alright, so welcome back to everyone. A very warm welcome to all of you, my dear students. A very warm welcome to all of you. So guys, I hope you guys can see me and hear me properly. आप लोग मुझे ठीक से देख और सुन पा रहे हैं. So guys, now in this session, I'll be continuing with the vectors. So before that, my name is Dr. Umashankar. I'm your physics educator, and on this channel, we are trying to complete the physics for NEET 2024 in all the respects. Okay. Now in this line, we have already completed the units and measurement, and we are into kinematics. So in kinematics, we are parallelly doing two things. One is, the vectors, and the other is what? The other is the motion in a straight line, right? Other is the motion in the straight line. Okay. So guys, in the last session, we have spoken about this vectors, right? So in the last session, guys, what we have been talking about? So in the last session, we were discussing about the vectors, okay? And we started with the vector multiplication, right? And before that, we have seen how to do addition of the vector, how to do subtraction of the vector, how to, deal with the basics of the vector, what is its use, how to deal with it in Cartesian coordinates and everything, right? Okay. So in vector multiplication, guys, we have seen about the scalar product, which is also known as the dot product. Okay, and we have seen about the vector product. We have started with the vector product, okay, or cross product. Same thing. Okay. Okay. So in the case of vector product or cross product or a scalar product and dot product, what is the basic difference and why it is called as the scalar product? Because see, the end result of the multiplication when you are doing the dot product of it and when you are doing the cross product of it, so the basic difference comes where in the scalar product what happens, scalar product dot product what happens. So here the final solution will be a scalar quantity, and when we do the vector product or cross product, the final solution will be the vector quantity. Okay, I hope we are able to understand that, right? Okay, I hope you were able to understand this, right? So now in this case, I'm hoping that there is no doubt as such. Now in the last session, we have discussed about the vector product or you say cross product. So I'll just give you a brief revision of the same. So see vector product or cross product. So when we have the scalar product, when we do the scalar product or dot product of two vector, this comes out to be AB cos theta, where AB is the magnitude. Hello Bima, very good afternoon. Welcome to the session. Okay, and now AB cos theta, and so this is a scalar. This is a scalar. So we didn't wanted the direction of it. So this one is a scalar. We knew it. Okay. Now in the case of the cross product. So in cross product, what happens? So when we are doing the cross product of So when we are doing the cross product of this A cross B vector, when we are doing the cross product of A cross B vector, then what happens? So we get AB sine theta. And I told you this is the magnitude of this vector. This is the magnitude of this vector. And also we have understood that, so it needs a direction also. Okay, so because the cross product of two vectors is also a vector. So this has to be a vector. So to explain any vector, what we need to have? We need to have the direction of that vector as well. See, any vector is defined by two things. One is magnitude, one is direction. Okay. So when we do A vector cross B vector, we have the magnitude of it as AB sine theta and the direction of it as n cap. Okay, the direction of it as n cap. So n cap is the unit vector in the direction of this A cross B. Okay. Okay. So the magnitude of this cross product we have AB sin theta, and for direction we have n cap. So how we get this direction, sir? So we get this direction from right hand thumb rule. Okay, from right hand thumb rule. Okay, so we have spoken about it in detail in the last session. Okay, so in this right hand thumb rule, what do we do? In this right hand thumb rule, beta, what do we do? So see, in the right hand thumb rule, so let's suppose, so see, like for example, okay. So if there are two vectors, so let's suppose we have a plane, just giving you a brief uh, what happened till now in the cross product. So see, in this we had two vectors. So let's suppose one vector is A vector, another vector is B vector. Okay, and the angle between these two is theta, and these two lies in this plane. So what happens? What happens if we want to write A cross B vector? Okay, so we require the magnitude of it. We require the magnitude of it. So what is the magnitude, sir? AB sine theta. So clearly we'll get the magnitude. And remember, theta is what? It's smaller angle. This is also important thing to understand. It is the smaller angle between vector A and vector B. Okay. So this is the smaller angle between vector A and vector B. And then we'll have to write the direction of this vector. Okay, so about the direction, there were two concepts we have left understood. So we can get the direction by the right hand thumb rule. Also one more thing that was important, that this is perpendicular to vector A and B. Okay, this is perpendicular to both the vectors. So basically, it is in the plane which is perpendicular. It is in the plane which is perpendicular to the plane of vector A and vector B. Okay, so if this is the vector, so what is going to be the plane perpendicular to this vector or axis perpendicular to this vector? So, sir, obviously, this will be this axis which is perpendicular to this vector. Okay, perpendicular to vector. So, this vector can be in upward direction, this vector can be in the downward direction. Now, to know whether it is in upward direction or whether it is in downward direction, we are supposed to use the right hand thumb rule. So for that, I told you what, so we need to use our right hand. So we'll keep this point, okay, at the juncture of these two vectors. Now we are writing A cross B, so I'll have to place my right hand in a way that so we need to place our right hand in a way that we are having the fingers to curl from the initial vector to the final vector. So here the first vector is A, the second vector is B. Okay, so if I place the fingers like this, then only it will curl from A to B. Now, if you place your right hand properly, then the direction of this thumb is going to give you the direction of this vector. Now, in this case, what's going to happen? So we are placing our thumb like this, okay, and we are moving or we are curling our fingers in the direction from A to B. Now, when we are doing it, our thumb is pointing upwards. So this is going to be this direction. This is going to be this direction. So let's call it C vector. Okay, so this vector it is going to have in the direction of C. So we'll write it as C cap. Now, if at all we have to write B cross A. Now, in that case, we have to place our hand. Obviously, we have to place our hand like this, the reverse position, because we are now have to move from B to A. So, if we want to move from B to A, our right hand thumb will be pointing downwards. So, in that case, what happens? So magnitude will remain unaltered, will remain unchanged. It will be this only, and it will become minus C cap. Okay, because this vector C we have considered now. Okay, so basically to this, what was the outcome? So I hope from this you understood to see the direction of a vector using this, right? Am I right? Yes or no? Do we have any doubt in this? So that we can move with the special cases and we can move up with the properties, and further we can move up with the cross product of orthogonal unit vectors, because ultimately we need to reach to the Cartesian form. right? Okay. Can you answer me that? Okay. Okay, so I'm hoping that this is clear. Now, see, so we have seen some special cases too in the last session, just giving you a brief review of it because this is going to be applied in a lot of manner today. So what were the special cases? So if theta is equal to 0 degree, if theta is 0 degree, that means vector A and vector B. So if the angle between two vectors is 0, that means they are parallel vector. So if two vectors are parallel, so what is going to be their vector product? So this is going to be 0 vector. Okay, and remember, this is 0 vector. This is a vector because cross product of two vectors is always a vector. So when you are when you are doing the cross product of two vectors and afterwards if you are getting 0, so that is not a scalar but a vector. Okay. Okay. Similarly, if theta is equal to 180 degree, that means the vectors are anti-parallel vectors. The vectors are anti-parallel vectors. In this case also, it is going to become 0. Okay, in this case also it is going to become what? It is going to become 0, right? And now if the vector is at 90 degree, if the vector is at 90 degree, okay, if the vector is at 90 degree, that means if vector A is here, vector B is here, the cross product of these two vectors in magnitude is going to be, so we know to see the direction, so I'll be writing the magnitude, so it will be AB. Okay, that means vector magnitude of A multiplied with magnitude of B, and you will be getting the magnitude of A cross B simply, and this is has to be the maximum magnitude, right? This is the maximum magnitude. Okay, because what is the maximum value of sine theta? The maximum value is +1, minimum value is -1, right? Okay, okay, so this has to be the maximum value, right? Okay, okay. Now afterwards we have seen some properties of the vector. First one was, so I have spoken about all this thing in the last session. So vectors are not commutative. Okay, so they do not follow commutative law, but they do follow this. So if the cross product of two vectors, if I write, it will be minus of the cross product of if they are reverse in order. Like A cross B is also equal to minus B cross A or vice versa. Okay, so when you reverse the order of vectors in vector multiplication or cross product, what is going to happen, Beta? What is going to happen? So we are going to have this thing that a minus will appear. That means the negative of the vector will appear in the question. Okay, and this is we have explained. Okay, then second was that the vector cross product obeys the distributive law. This obeys the distributive law. Now, what does that mean? So it obeys the distributive law. That means that you can take this cross product just like the algebraic multiplication within this bracket. So when we take this within this bracket, we'll be getting this. We'll be getting this. But remember, you cannot reverse the order. So this is okay. Now the third thing was that cross product of a vector with itself is equal to 0. The cross product of a vector with itself is going to become 0. Right? Okay. Now this much we have done in the last session, Bida. This much we have done in the last session, and I hope that we do not have any particular problem in this. Right? Wonderful. Okay, now let's talk about the cross product of orthogonal unit vector. Cross product of orthogonal unit vectors. Okay, cross product of orthogonal unit vectors. Very important. And this is going to be the basic of the discussion of vector product. Okay. Now in this case, what happens? Please observe. So this is going to be x, y, and z. Okay. Now we understand that what are the orthogonal unit vectors. So we very well knowing this. That's the Orthogonal unit vector are I cap, which shows the direction of x, j cap, which shows the direction in y, and k cap, which shows the direction of z. Okay, okay. This much we understood previously, and we also know to write. Yes, we also know to write that what is the vector, what is how we write a vector in Cartesian. Okay, we have been doing quite a few things in this Cartesian. We have seen addition of two vectors in Cartesian, subtraction of two vectors in Cartesian. Then we have seen the dot product in the Cartesian, how we can write the Cartesian form, how we can come up with the resolution, and also in the last session we have seen what is the angle made by between what is the angle between two vectors. Okay, also we have seen like what is the angle of a vector from the x, y, and z coordinate axis. So all this thing we have seen lastly, right? Now I am assuming that we are knowing all these things. So now we have I, j, and k. Now let's apply the understanding that we have of vector in this. So if two vectors, if two vectors are multiplied with each other. So what we have learned, if a vector is cross product, the vector product of a vector with itself, or a cross product of a vector with itself, is going to be zero, because see what is the angle a vector will make from itself. So obviously, sir, it is going to make 0 degree, and sine theta is equal to 0. So simply we can write I cap cross I cap is equal to 0. Okay, remember in the case of the dot product, I dot I was 1. So I'll just write that also here so that you have everything like, so I cap dot I cap. So dot product was, the dot product was 1 beta, right? Now we have j cap cross j cap. Okay, so since the angle between two vectors, or a vector when cross product with itself, it is going to lead you to the 0. Hello Shitai. Okay, so we have just till now we were revising that what we have done in the last session, and now I am continuing ahead, just started continuing. Okay, so till this point whatever I have taught we have already discussed in the last session, and now I am continuing further. Okay, beta. So J cross J. So we have learned in the last session, no, that are vectors, the properties of cross products. So a vector having, if a vector is cross product with itself, it is going to lead you to the 0. Now in the same way, I cap cross I cap is 0. J cap cross J cap is equal to 0. K cap cross K cap is equal to 0. And in the case of dot product, what happened? So in the case of dot product, j dot j is 1, k cap dot k cap is equal to 1. Right? We remember all this now. Okay. K cap dot k cap is equal to 1. Okay. Okay. Now please observe something very, very interesting. So now if we remember this thing, I guess that if two different orthogonal unit vectors are dot product with each other, like if I write I dot I cap dot j cap, okay, this becomes 0. Okay, because for the scalar product we get the cos theta thing. So when we do the cos theta thing, cos 90 is 0. So basically two orthogonal unit vectors, when they are dot product with between them, it becomes 0. Okay, now if we have similarly I cap dot k cap, this was also 0, and if we have j cap dot k cap, it is again going to become 0, right? But it is again going to become 0. I hope it is clear to everyone, right? Right? Okay. Now talking about the cross product, beta. Talking about the cross product. So if I do the cross product of I cap dot j cap, what we are going to get? So sir, when we are doing the cross product, we have to have the resultant, or the result has to be a vector. So when the result has to be a vector, what is the magnitude of, so how we write it? The magnitude of I cap. So when two vectors having the cross product, yeah. two vectors, but we have to see something also. So I cross I cap, okay, into j cap, mod of I cap, j cap, okay, in the direction. So what is going to be the direction? So we understand that, so cross product of two vectors, the direction will be perpendicular to the both the vectors. Now, what is this ijk? So we understand this ijk, right? This is ijk, right? In general, these three fingers you can see. So this is, I, this is j, and this is k. Now, please understand, it's very simple. This k is perpendicular to both I and j. The k is perpendicular to both I and j. So that will be the direction of the cross product of I and j must be in the direction of k. But the question is whether it is in positive k or it is in negative k. Now for that, what we have to do? What we have to do? So see, we have to place the thumb like the way that it is from I and goes towards J. Now, if the finger is to curl to reach from I to J, you must be placing your hands like this, isn't it? So when you will be placing your hands like this, so then only your finger curl from I to J. So it will become towards K, isn't it? Okay, so this is going to be the direction is going to be positive of K, positive of K cap. So I cross J cap will become K cap. Are you getting my point? Beta 1 K cap in positive. 1 K cap in positive. Now, similarly, if I say what is going to be J cap cross K cap. So, sir, firstly, it is going to be, so see, what is the direction perpendicular to J and K? Bima, I hope you are getting this. So, what is the direction of the vector perpendicular to both J and K? So it must be I. It must be I, but it will be positive I or negative I. So for that we have to use right hand thumb rule. So J cross K we are writing. So J cross K, now please see J cross K. So you want to curl your finger from J. So this is J, na? This is Y. This is J. Okay, your palm is like this. And now when you are curling it towards the jet, this must be the curl. So this is going to be your vector. This is going to be your direction of the vector, isn't it? Where the thumb is pointing towards the positive I. So basically it will become, so magnitude of, unit vector is 1. Okay, what is the magnitude of unit vector? 1. So what is the magnitude of I cap? It is 1. What is the magnitude of j cap? It is 1. So that is going to be 1. Okay, but what is going to be this? So it will be plus I cap. Okay, now similarly, if I write k cap cross I cap, okay, so definitely it is going to be j cap. Positive, negative we can check. Positive, negative we can check by the right hand thumb rule. So now this is your k and you want to shift towards x. So you must be placing your fingers like this. So this is k, this is k, and you want to shift towards x. So this is going to be your vector direction. So basically it is going to be positive j. Understood? Okay. Okay, now we just have seen this. So if I cross j is k, so that means j cap cross I cap is equal to k cap with a minus sign, right? We just have seen this now. See, a cross b is equal to minus of b cross a. A cross b is equal to minus of b cross a, right? So similarly, if I cross j is k cap, then j cross I cap must be minus k cap. If j cross k cap is I cap, that means k cap cross j cap must be minus of I cap. And also, if k cap cross I cap is equal to minus of j cap. Okay, is equal to minus of j cap. Now, I think you must be developing some, synergy in your mind. So, I cross product with j, you get the k. Okay, so when you are cross producting two unit vectors, you are getting the third vector. And positive, negative, you can see by the, isn't it? I hope this is clear up to this point. Yeah. Yeah, I hope this is clear up to this point, right? But do you realize that if we are using the right hand thumb rule in the examination, it is going to take some time also, right? Oh, should I? Okay, you can manage at least, na? Okay, but like we feel that this could be very time taking in the examination if we start, because the IJK form of vector is very frequently used now. Every time if we using right hand thumb rule starting to know that whether it is positive negative, it is going to take a lot of time. So we are not going to do that. So I'll make a shortcut for it. So let's suppose, so we have I, we have J, we have K. So let's write them in this sequence. Let's write them in this sequence. Now let's see. Now let's see what is going we are going to do. Now if we are moving from I to J, see, whenever we are moving from one vector to another vector in clockwise sense, you must write the positive. So see, very simple. See, you'll see like a loop. So I cross J, it becomes, so we are moving in clockwise, so it is plus K cap. If J cap cross K cap, so from J to K we are moving in clockwise. So remember the sequence I J K, and it is very easy to remember. Na? I cap, J cap, K cap. Now from J cap to K cap, if we are going, so obviously we'll getting the next vector, that is the I cap. And are we going to get the positive or negative? You can see by seeing this clockwise or anti-clockwise. So from J to K we are moving in clockwise sense. Okay, so from J to K we are moving in clockwise sense, so we are getting plus I. Now from K cap to I cap. Now from K cap to I cap, so we can do K cap cross I cap. What we are going to get? We are going to get the next vector, that is the J cap, and we are moving in positive, so will be positive. Okay, it will be positive. Now please observe. So if we move in the negative sense, let's suppose we move from I to K. So this is anti-clockwise sense, na? So anti-clockwise we are going to take as a negative. So I cap cos K cap is equal to minus J cap. Okay. Now if we move from K cap to J cap, because in the examination you cannot do each everything. Na? So whenever you are solving the question, you can write this in the side and you will be knowing that whether we are getting the positive unit vector and whether we are getting the negative unit vector. Hello Ankit, welcome to the session, my dear. Okay, so we are continuing from the last session and we are seeing the cross product of the vector. And this is going to be the last session of the vector. I'll be completing this vector today itself so that we can continue with our physics. So now see, from K to J cap, we are moving in the anti-clockwise sense. So what is the next vector? The next vector is I cap. And are we going to get the negative? Yes, sir, we are going to get the negative because we are moving in an anti-clockwise way. Then J cap cross I cap. So see J cap cross I cap. So sir, we are moving J to I. This is anti-clockwise term. So we are going to get the negative, and this is going to be the next vector. So is this clear how we have done it? It is simplified, I think, to some extent. What do you feel? Yes or no? Yes or no? So this is a kind of shortcut. Okay. This is a kind of shortcut. Yes or no? Please answer me. Right? Bhima, did you get this? Ankit, did you get this, Vida? Okay, I hope this is clear. Now let's use this concept in the uh, in doing the cross product. In doing the cross product of two vectors. Let's do the cross product of two vectors when vector A cross vector B. So two vectors when A vector and B vector are in Cartesian. Okay. So if two vectors are given in the Cartesian form, we need to do the cross product. We need to do the cross product. So we already have done the dot product of two vectors, right? We already have done the dot product of the two vectors. Did we or didn't we? Okay. Yes, sir, we did. So now what is going to be the cross product of two vectors when A and B are in Cartesian? Now what we are going to do here, see, very simple. You have to apply this way, and I'll be just giving you one shortcut also by using. So there is one thing called matrix. Okay. Okay. So I'll just give you a brief of finding the, for just for the sake of cross product, we need to understand that how to find the determinant. Okay, I'll just give you like a very easy way. Yeah, determinant law. Okay, it is going to be very easy then. But let's do first to try to understand that why it is happening, and so that it remains in your mind for a long period. So we must also know that how it is going to have. So let's suppose we have two vectors axi plus ayj plus b azk cap. Okay, and we have another vector. Let's suppose b vector, and this b vector is bx of I cap plus by of j cap and by of, sorry, bz of k cap. Now you want to find what is going to be a vector cross b vector. Okay, a cross vector b vector. Now please understand this. So when you are doing the cross product in the Cartesian, you don't need to use the right hand thumb rule, because the final direction will be given by ijk itself. Okay. Okay, so right hand thumb rule is also not required to be used here. Okay, so simply what we can do, see. So we have a vector cross b vector. Now see, very simple. So in the dot product, what we were doing? So we were doing the product of, or we simply do the algebraic multiplication of the I components, the y components, and the k components. Okay, we were doing the simple algebraic multiplication in the case of the dot product for the I component, j component, and k components. But here, see, it is a cross product. So I cross I is going to become 0. J cross j is going to become 0. K cross k is going to become 0. So in your mind, I think you must be understanding this, that I component is going to multiply with the j and k. Similarly, j component is going to multiply with I and k component is going to multiply with what? I and j. So simply let's do the multiplication. Let's write it here so that we don't make any mistake. Now see, we are going to do this. So right away I'm writing. See, a vector cross b vector. So what is going to be the a vector cross b vector? So it is going to be, see, so ax by. Okay. Now what is going to be I cross j? So for I cross j, we are moving clockwise. So it will become plus k cap, right? Now axi and bzk, ax, bz, and I cap cross k cap. So I cross k cap, I cross k cap. Yeah. So this is ax, by, and this is going to be k cap. We already have written it. Now axi and bzk. So axi and bzk, it will become plus ax, bj. Now please understand this I cross k. So I cross k, we are having the anti-clockwise sense. Okay. So when we are having the anti-clockwise sense, we are getting the next unit vector in the negative. So we'll get minus j. See, very simple. Now similarly, if I do with ay, so ay I have to do with I and k. So let's write it right away. So it will become ay bx. Okay, now j cap, I cap. So again, we are moving in anti-clockwise sense. So anti-clockwise sense, that means we are getting the minus one. So it will become minus k cap. It will become minus k cap. Now ay, so this is going to be multiplied with the k factor. So ay bj, ay bj. Now see, j cap to k cap. This is a clockwise thing. So j cap to k cap, it will become I cap. It will become plus I cap. Now let's come back to this k factor. So that is azk. Now azk multiplied to this thing. So it will be multiplied with I factor and j factor. So this will become az k cross I. So k cross I. Now please observe az bx. See if let's see. So just be careful. If I miss something, do tell me. So az bx. Now it will be k cap cross I cap. So k cap k cap plus I cap, that means we are moving in the clockwise. So we'll be getting the j cap in the positive. We'll be getting the j cap in the positive. Right now, AZ k cap into by j cap. So it will become plus AZ by and k cap j cap. This will become minus of I cap. This will become minus of I cap. Did you get it or not? Please answer me. How we did it? Yes or no? Please answer me, my dear. Did you get it or not? Please answer me. Some network issue are you facing? She's saying. Yeah, it's okay, beta. I hope this is clear to everyone. She said it might be some problem from the server end also. Yeah, okay. Okay, so I hope this is clear to you. Okay, now can I rearrange this like this? Now please observe if I am rearranging it. So now I can write A vector cross B vector, A vector cross B vector. So I'll write I component together. So I'll be getting AY BZ minus AZ, AY BZ minus AZ BY into I cap, right? Into I cap. Then we are having, so if I now combine the J component together, I'll be getting, sir, AZ BX minus AX BZ J cap. Okay. AZ B cap J cap, AZ BX minus AX BZ J cap. And if I combine this K cap thing together, so we'll be getting plus AX BY minus AY BX K cap. Understood, beta? Please answer me. Yeah. So this is the simple vector product. So if you have, see, this seems to be very complicated, no? Or AX, BX, BY, BZ. But you see, whenever a vector is given in the Cartesian, you will be having some values there. So it will be multiplied, all this AY, BX, BZ, all this thing will become a numeric value. Then it will look better. And when you have a vector in the Cartesian format, you very well understand that's how we can get the magnitude of it, and IJK will give you the direction. Understood? Understood? Okay. Now there is one shortcut to it. So for that, I'll just tell you how to find the determinant of a matrix. See, very simple. How to find determinant. Okay, so this is one mathematical tool. Just very simple. How to find the determinant. Okay. So see, see, let's suppose this is, just let me take some random value, 2 1 1 3 2 1 4 2 and 6. Just randomly I have taken. Okay. Now how we are going to find the determinant, please observe. So see how we are going to write. Very simple. So you will be writing what is this? So this is the sign of determinant. Okay, so actually this is the matrix. So when we write the matrix, it is like this. Now every matrix has a determinant. So we don't have to dig very deeper into it. Just come to know this. Very simple. So see what is going to happen. What is going to happen? So it will become, see, you will write like this. So 2. Okay, so when you are writing here, so see, remember the sequence, plus minus plus. Okay, so we'll take the first row. This is the row of the matrix. So plus minus plus. So plus 2. See how we are going to write plus 2. Now just imagine a line over here. This and this. Cross it. Okay. So you will be left with this 4 thing. Okay. Okay. So just imagine, because if I make it like this, then you will get confused and it will look bad also. So just now when you have picked this 2, now this is a row, this is a column. You are not considering that. So see how you are writing. 2 cross 6. This is not a cross product, it's a simple algebraic multiplication. 2 cross 6 minus 1 cross 2. Are you getting the pattern, beta? Are you getting the pattern? So when you taking this 2, so first thing positive. First thing is that it is to be taken positive. Then you write it here inside the bracket, this multiplied with this minus this multiplied with this. Okay, I hope it is clear to everyone. Now see, if I move forward, so plus 2 minus 1 plus 2 minus 1, I came to this. Now I am putting, line on this. Okay, so I am not seeing these two. This has to be happen in your mind. So plus 2 minus 1. Now minus 1, so when we put the line over it, so we have this 3 6 and 1 4. So 3 6, so 3 into 6 minus 1 into 4. 1 into 4. Now the third one is with plus 1. Now third one is with plus 1. So third one is with plus 1. That means CL. Okay. 3 into 6. Okay. So I'll write. I hope you come to understand this. So 3 into 6 minus 1 into 4. Right. Now similarly we move to this one plus 1. Now when we reach this plus 1, see again how we are going to write plus 1. How we are going to write plus 1. Now we put a line over here. Imagine that you have put a line over here. Then we'll have this 3 into 2. Okay. And then again minus 2 into 4. Minus 2 into 4. Understood, Bida? Very, very simple, no? Very, very simple. Right? Yes or no? Yes or no? Please answer me. Okay. Very simple, na? Right? Now the same funda we are going to apply here. The same funda we are going to apply here. So see, this is a shortcut to find because this is getting very lengthy now this way. Every time you have to think whether it is positive, negative, what so. Okay. So this is going to be a bit lengthy. Yeah. First of all, did you get the determinant thing or not? Please answer me. Did we get this determinant thing or not? Please answer me. Did we or didn't we? Did we get the determinant thing or not? Everyone. I hope we got this determinant thing, right? I hope we got this determinant thing. Right? Okay, wonderful. So now when we get this determinant thing, so we can now proceed further. So see, we have, let's suppose, a vector A. Now again, I'm doing the same thing. See, this is going to be AX of I cap plus AY of J cap plus AZ of K cap, right? AX of I cap, AY of J cap, AZ of K cap, and we are having another vector that is B vector. This is BX of I cap. Okay, this is BX of I cap plus BY of J cap plus BZ of K cap. BZ of K cap, right? Now we want to find the cross products of A and B. We want to find the cross product of A and B. So see, we are using this shortcut determinant method. So see, in this case, so sir, we can do like this also. Okay, so you can do like this also, but this is quite lengthy first of all. Secondly, it is very much prone to mistakes. It is very much prone to mistakes as well. So how it is prone to mistakes? Because see, you have to see whether a cross product of two unit vector is positive, negative. So you may make some mistake there. But this is mistake proof. See, very simply we have to write. See how to write in the determinant format. So see, A vector. See, very very simple. A vector cross product with B vector. This is going to become see determinant of. Okay. See, we'll write like this: I vector, J vector, K vector. Please observe the pattern. So I cap, J cap, K cap. Then we'll be writing the AX. We'll be writing the AX, AY, AZ. Okay. We'll be writing BX, BY, BZ. Okay. In a very simple manner, we have given it a format of the determinant. We have given it a format of the determinant. Right or wrong? Understood? Okay, now simply see how we have to write. See, we have to use the rule that we have learned from multiplication of finding the determinant. See, I cap, okay, it will become see ay bj ay bj, okay, minus az by. Sir, how we are doing it? So when I'm writing I'm just considering these four. Okay, so you do like this, you do like this. This one is positive, this one is negative. See, very easy pattern, right? Okay, now this first thing is plus, the second thing is minus. So we'll write minus g cap, minus g cap. Now I'm writing the minus g cap, so I'm considering these four. I am considering these four. So this will become ax bj. This will become what beta? This will become ax bj. Okay, minus AJ BX, this is BX, right? AJ BX. Now we move to this K cap. So see, plus minus plus. So it will become plus K cap. Okay. And see, when you are taking this K cap, you are considering these four. Okay. So this will become, see, AX BY, AX BY minus AY BX minus AY BX. Now you can see that we are getting the same thing as we have got by multiplication each and every component, separately. Is it fine or not? Please answer me. Please tell me yes or no. Did you get did you get this or not? Please answer me. Everyone. Very, very simple. Now, very, very simple. So sometimes when we see this AY, BZ, AZ, BY, it seems too difficult to us, na? But it's not like that, na? So you will have the number values. So when numbers are there, you will like it more. Okay. So now please observe. Okay. So let's observe a question. So if simple. So if A cap is equal to 3 I cap, 3 I cap plus j cap plus 2 of k cap, and b vector is going to become b vector is going to become 2 of I cap minus 2 of j cap plus 4 of k cap. So you need to find the cross product of a and b. Can you do that, beta? Can you find me the cross product of a and b? Please go for it. I'm very sure we can do it. Get me the cross product of these two. Get me the cross product of these two. Please try to give me that. Please go for it. Please go for it, my dear. We need to now get A cross B vector. Can you please give me what we are getting? The live student can tell me what we are getting from it. Please go for it. What are we getting? Are we getting anything, beta? Let's try to do it. The cross product of these two vectors is going to become what? Please observe. Please do it. Let us try, beta. Let us try. Any answers? So if A vector and B vector are this and this, what is the vector product of A cross B? So what are we going to get from here? So see, simply just after seeing it, just start writing in the determinant form. So we'll write I cap, J cap, K cap. Okay, and this will become 3, 1, and 2. This will become 2 minus 2 and 4. So right away, see how we can write. So see, you don't have to like also write everything. See, I cap. Now see, first thing will be plus I cap. So 4 minus minus 4. So it will become 8 of I cap, isn't it? See, do it in your mind only. Okay. See, 1 into 4, that is 4, minus 2 minus 2. Okay, so minus of 2 into minus 2. So it will become 4 minus of minus 4. So it will become 8i. Now simply again for j cap. So j cap is going to be, now see, you just think in your mind that you are not seeing the column of the j. Okay, so left values are 3, 2, 2, 4. So 3 into 4, it will become 12 minus 4, that is again 8j, right? So we are getting minus 8j. See how I have done it? 3 cross 4, 3 into 4, that is 12, minus 2 into 2, that is 4. So 12 minus 4, that is 8. Now let's come to this k thing. So now after plus I minus j will get plus k, plus minus plus. Remember this. Okay. So it will become 3 minus 2, that is minus 6, and minus 6 minus 2, minus 6 minus 2, minus 6 minus 2, uh, minus 6 minus 2, it will become minus of 8. So can I write it here? Minus 8 of k cap right away. See, just in a go you can do it. Okay, so you have this A cross B now. Now, if they are asking you that what is the magnitude, what is going to be the magnitude of it? So simply the magnitude is going to become root over. So we know how to get the magnitude of a vector in Cartesian. So it's minus do nothing. So it will become 8 root 3. Please answer me, Bida. Is it clear or not? Please answer me. Please answer me. It will become 8 root 3. Okay. Now, did you get this thing or not? How to do the vector? Please tell me, did we get it or not? How to do with this vector product? Yes or no? Please answer me something, Bida. Sri Sai, Bhima, any other students who is live right now, you can answer me. Very important concept. Any answer, Bida? Brilliant. Please answer, Bida. I'm hoping this is clear to everyone. Yeah. Okay. So let's move forward. So let's try one more question. So see, this concept is used at many places in the physics. Let me give you a question of rotational mechanics. So find the torque of force vector Let's suppose the fourth vector is 2 cap minus 3 of j cap plus 4 of k cap Newton. Okay, acting at a point, acting at a point, acting at a point r cap. Okay, r cap 3 cap plus 2j cap plus 3k cap, and the unit is meter. Okay, about the origin, about the origin. Okay, about the origin. So options are 17 I cap minus 6 of j cap minus 13 of k cap. Option B is 17 of I cap plus 6 of j cap minus 13 of k cap, right? Minus 13 of k cap. Now option C is 17 of I cap, okay, minus 13 of j cap, okay, minus 7 of k cap. And option D is going to be 17 of I cap minus 6 of j cap plus 13 of k cap. Now, can you please try this question? I'm very sure we can do it. Please go for it. See, very, very simple. Please go for it. Can you please try it, beta? Can you please try it? I'm very sure we can do. Please go for it. Please try it, beta. Please try it. Any answers from the live students? Very simple question, beta it is. Right? So in the last session, I told you something when I was explaining you the relevance of this cross product. I have given you this example, right? Okay. So torque is basically a vector quantity. It is sort of a force only, but I told you what. So torque basically rotates the body about some point. Okay. Okay. So if a force acting in a way that it rotates the body about one point, then we call it what? Then we call it the uh, torque, right? So what is the torque? So normally we represent it like this with this sign of tau. Okay, so this tau vector is going to be r vector cross f vector. Remember, I told you this in last session also that this is the displacement vector cross force vector. Okay, okay. Now what is going to be this cross product? So we have r and we have f. So let's write it. So see I j k. Okay, and don't make the mistake of because see cross product is not commutative. We have seen the properties now. So this is not commutative. So if r vector is first, f vector is the second. So let it be like that. Don't make it f cross r. Right? Now ijk. So we'll have. So see what is r vector. So this is 3 2 3. Okay, sometimes in hurry we make this mistake, na? That what we do, we write which vector is given first and which vector is given second. No, you'll have to see. You'll have to see. Okay, no, Bima, wrong answer, beta. Okay, so just I have written the values. Just I have written the values. Okay, okay. Now I'll be writing the determinant. See, very very simple it is. How we are going to do it? So firstly, it is I. Now see how we are writing. So see, we have to do it in our mind. We have to save some time also. See, 2 cross 4 minus of 3 into minus 3. So 2 cos 4 is how much? 8. Okay. 8. Okay. And this is minus of 9. So 8 plus 9, it will become 17 of I, isn't it? It will become 17 of I. Now moving to J. Okay. Now for J, we'll have to see this. So J, so you are seeing this 2 and these 2. So this is going to be 3 into 4, that is 12 minus 6. So 12 minus 6 is minus of 6J. Now we are going to see for K. So for K, we are seeing this one, this one, this one, this one. Okay. So it will become 3 minus 3, that is minus of 9, minus of 4. So minus of 9, minus of 4, this will become minus of 13. This will become minus of 13, beta. Right? This will become minus of 13. So this will become 79 minus 6J minus 13K. So that is going to be the A option. Is it clear, beta? Vima? Yes or no? Yes or no? Please answer me, my dear. Is it clear, beta? Is it clear to you? Please answer me. I hope it is. Now let's move to one more question. Now, if it says, so if two vectors, so if we say if two vectors, let's suppose 2 I cap plus 3J cap minus of K cap and minus of 4 I cap minus of 6G cap plus lambda of K cap, okay, are parallel to each other, or what are parallel to each other, okay, parallel to each other. Now what we have to do, so we have to find the value of lambda. Then we have to find the value of lambda. Okay, so we'll be getting, see, I'm giving you some options. Okay, now I want you to do this. Please go for it, beta. I'm very sure we can do. Please go for it, beta. Let's try it, beta. Let's try this, beta. I'm very sure we can do. Give me an answer, beta. Very, very simple. Please go for it. Very, very simple. Please try to think the concept we have learned, and I'm very, very sure that you can do it. Please try it. Any answer, beta? Any answer, beta? The option? The option? Let's see. So, no, beta, something is missed. Now, please understand this. So, it says the two vectors are like this, are parallel to each other. So, when two vectors are parallel to each other, beta, when two vectors are parallel to each other, what is going to happen? So, let's suppose this is vector A, this is vector B. Now, if vector A and vector B are parallel to each other, their cross product must be a zero vector. Okay, isn't it? The cross product must be a zero vector. Do you agree? Yes or no? We learned it now. Because if two vectors are bit parallel to each other, that means the angle between them is zero. And when the angle between two vectors is zero, the cross product between those two vectors is going to become zero. So we can write A vector plus B vector is a zero vector. So what we can do, we can write the determinant. So what is the A cross B? So I can write I, J, K, and this is 2, 3, 1, minus 1, and minus 4, minus 6, and lambda. Okay, so this is going to become 0. Now we can get the determinant of it. How we are going to get C? See how it will become. So it will become I. Now see 3 lambda minus 6 minus j cap. So j is 2 lambda, and this is going to be minus 4, and for k it will be 2, yani that is minus 12, and this is going to be minus and plus 12. This is equal to 0 vector. Do you agree? Just take in the determinant of it. So this will become 3 lambda minus 6 of I cap, 3 lambda minus 6 of I cap, minus of 2 lambda minus 4 of j cap, okay, and plus 0 of k cap, and this has to be equal to the 0 vector. This is to be equal to the, please answer me, right? Wonderful, sir. Now see, this is 0 vector. So when this is 0 vector, this will go like this: 3 lambda minus 6 of I cap minus 2 lambda minus 4 of j cap plus 0 of k cap, and this is going to become 0 of I cap plus 0 of j cap plus 0 of k cap, because this is a 0 vector. That is the relevance of 0 vector. See, I told you in the basics now that we have a null vector, we have a 0 vector. So when we have a null vector or when we have a 0 vector, beta, when we have a null vector and when we have a 0 vector, okay, Okay, so when we have a null vector and when we have a zero vector, so we can give it an arbitrary direction. Okay, so you can write the zero vector like this: 0 I cap, 0 j cap, and 0 k cap. Now you can have the I components compared for both left hand side, right hand side. So it will become what? It will be 3 lambda minus 6 is equal to 0. So lambda is going to become 2. Okay, 2 lambda minus 4. 2 lambda minus 4 is equal to 0. So again lambda is equal to 2. So what is going to be your answer, beta? Your answer is going to be lambda is equal to 2. Clear? Please answer me. Please answer me. Yes or no? Right or wrong, beta? Please answer me. Very simple, na? Now this cross product has, so when you will be seeing the angular momentum in rotational mechanics also, there you can use the cross product. In the magnetic field also you can use the cross product. So it has multiple use. So I hope that this cross product thing is clear. We can do the question in the 75-day challenge thing. More question. I'll come up with 2 3 more questions there. But let me finish this. I want to finish this vector thing today. So there are 2 3 more concepts are left. Let me deal with it. Shall I proceed with any doubt in this? Do we have any doubt in this? Shall we proceed? Fine, everything now? Yeah. Okay, so let's proceed. So see, there is one more concept. So if you want to have the area of a triangle, see, area of a triangle. So let's suppose we have a vector A, we have a vector B, and we have a vector C. Okay, we have a vector C. Okay, so basically what happens if you want to find the area of this triangle, if you want to find the area of this triangle, what you can do with that? What you can do? So what is the area of this triangle? Area of any triangle in general. So area of triangle is half base into height. Okay, we are absolutely aware of it. Half base into height. Yes or no? Yes, sir, definitely, sir. Now, what is this base? So, base is the magnitude of a vector, isn't it? Okay, base is the uh, base is the magnitude of this a vector. Yes, sir, agreed. What is this height? So, this height is going to be this now. And if let's suppose this angle is theta, if let's suppose this angle is theta, if let's suppose this angle is theta, so if this angle is theta, so see, if this angle is theta, so what is going to be this height? This is going to be b sine theta. B sine theta. Do you agree or not? Okay. And it has not to be any vector also. Like I just made this c vector, it has no rule. Okay. So what I'm trying to tell you, so if you want to find the area of a triangle is, so if any triangle is formed by any two vectors, okay, so you can find the area of those vectors. You can find the area of these vectors like this. Okay, area of these vectors like this. So like this. So what is this? So this is half. So AB sine theta, A magnitude, B magnitude sine theta. So this is nothing but the magnitude of A vector cross B vector. Okay. So when you are getting the magnitude of A vector cross B vector, okay. So if two vectors are forming a triangle, you can get the area by doing the half of their magnitude. Understood, Bida? Understood? Okay, so this is a useful concept. Okay, okay, okay. And also see in this, remember this also. So if you can check it also. So in this case, like if two vectors are forming a triangle, whether they are connected tail to tail, whether they are connected tail head, doesn't matter. You will get the same thing. You will get the same thing. Are you getting my point, Bida? Are you getting my point? So this helps you. So let's suppose I'll come up with a question. Don't worry. So sometimes what they do, so they give you two vectors in the form of Cartesian, and they ask you that what is the area of the triangle formed by with the use of these two vectors. Okay, you can do that. Now similarly, we can get the area of parallelogram as well. Area of parallelogram. Let's suppose we need to find the area of parallelogram using this concept. So what is the parallelogram? So here, this is let's suppose a vector. Let's suppose this is your B vector. This is our B vector. Okay, so this is the parallelogram, right? Okay, we have this is the parallelogram. Okay, now what is the area of parallelogram in general? So in general, okay, you are live now, Shreesai. See, Shreesai, we are almost done with the session. We are very soon going to complete this whole thing. Vector is about to get finished. This is somewhat the last concept. So you can just check the recording once. So what is the area of parallelogram in general, sir? So this is the product of base into height. Base into height. Now please observe what is the base of this parallelogram. So this is the magnitude of A vector, isn't it? And what is the height of this parallelogram? So this is going to be, so if this angle is theta, yeah. If this angle is theta, so this is going to be B sine theta. Now simply this is the magnitude of the cross product of vector A and vector B. So basically see what is the takeaway point. So whenever two vectors, see you can use the cross product between two vectors to find the area of the triangle and find the area of a parallelogram. Find the area of a parallelogram. Are you getting my point, beta? Are you getting my point? Okay. Okay. So if you want to find the area of the parallelogram, you can simply do the cross product of two vectors, get its magnitude, you will have the area of the parallelogram. For triangle, what you can do, beta? For triangle, what you can do, you can find the magnitude of the cross product of two vectors and then divide it by 2. Very, very simple. Now let's solve one question. So we are about to complete just one, two questions I'll give you and we'll be done with the session. So calculate the area of the triangle. Calculate the area of the triangle determined by two vectors. Determined by two vectors. A vector 3 cap plus 4 cap and B vector minus 3 of I cap plus 7 of J cap. So let's have the options as well. So 22 by 3, option B 33 by 2, okay. Option C 23 by 2 and option D is 13 by 2. Can you please try this question? I'm very sure we can do. Let's try to do this one. I'm quite sure we can do it. Please go for it. How we can get it? Very simple, beta. So see, very simply we can do. So we need to find the area of the triangle. So what is going to be the area of triangle? So it is half magnitude of A cross B. Okay, magnitude of A cross B. Now see, very very simple. So there is no K component. So we can use the determinant method or we can do right away. So first of all, see how to do it quickly. So 3 4 3 7. Okay, 3 4 3 7. So see, both the vectors are having ij. So definitely the other vector is going to be k cap. Okay, k cap. And this is going to be 21 minus 12. 21 minus 12, that is going to be 21 minus 21 and so actually this is minus 3i, sorry. So this is minus 3i, so it will become 3 into 7, 3 into 7, that is 21, and 21 and plus 12, that is 33. Okay, right away, see. Sir, I didn't get it. So see, you do the normal process. So can we write here 0 and 0? 0 and 0. So see, you are not going to get any I component, any J component. You are only going to get the K component. Okay, and this will be this. So 33 of K cap. So what is it going to be? If I take the magnitude, so it will be 33 by 2. So that is going to be the B vector. That is going to be the B vector. I hope it is clear to everyone, Bida. I hope it is clear to everyone. Now moving ahead, one more question. Now the value of, let's suppose, a cap, a vector dot a vector cross c vector is. Now please think before you answer this. So this is going to become a square into c, a mod, c mod, okay, c square, a, and d is 0. See how we can going to do it, how we are going to do it. Please go for it. Please go for it. Just try to do that. Very, very simple it is. Let's see who can do it. So how we are going to solve it, Bida? Very, very simple it is. Very, very simple it is. See, A dot A cross C vector. Now let's suppose we are getting a D vector from here. We are getting the D vector from here. So see, sometimes see these concepts are very important. So these concepts can lead you to the right answer of such kind of a question. So see, when two vectors are having their cross product, so when you do the cross product of these two vectors, what is going you are going to get? So we are going to get a new vector because the cross product will give you another vector always. Cross product is going to give you another vector. Now this vector is going to be at 90 degree with a vector, isn't it? This is going to be 90 degree with a vector. So why? Because we know that the cross product the cross product of two vectors is going to be in the direction perpendicular to both of those vectors. So see, this is going to be with 90 degree with A and 90 degree with C. Now you are doing the dot product of A vector with B vector, which is 90 degree with this. So it will become A vector magnitude, B vector magnitude, and this will become cos theta. So what is cos theta? This is cos 90. So this will become 0. Okay, so what is going to be your answer, beta? What is going to be your answer? Your answer is going to be D option, that is 0. That is 0. Okay, okay, okay. So dot product, see, simple concept, isn't it? So this is what we have learned. So basically, the cross product is also completed today. So now with this session, I can say that vector multiplication is also completed. That means with this session, vector is completed. See, vector is a so see, vector, basically I was saying vector is a chapter beta which you see having a lot of use in entire physics. You can see it's used in the forces, you can see its use in the angular, that is rotational mechanics. You can see its uses in the electric field, magnetic field. So a lot of use in kinematics, of course, Newton law of motion, of course, gravitation, of course. So many uses are there of vectors that this has to be done very, very properly. And I think with this session, whole of the vector is completed. I have covered the vector like in all the respect. I have given you everything in the vector. We started with the basics of vector, where we have learned that what are the type of vector, how to represent the vector, what is the angle between the vector. Afterward, we did the addition of vector graphically, analytically, both. And then further, we have seen that how we can use the concepts of the graphical addition and subtraction, analytical addition and subtraction. We have solved multiple questions. Okay. Okay, afterwards we came to this Cartesian thing, resolution of vector. Then we have seen how to do addition of vectors in Cartesian, how to do the multiplication of vectors in Cartesian, that is the dot product, the cross product thing. And we have seen many results, that what is the physical interpretation, how you get all those things. Okay. So guys, with this session, the vector is completed in all the respect. I hope you have understood the vector completely. And from the next session, we'll be starting with, again, we'll not starting, but actually we'll continue with our motion in a straight line. Now, kinematics not going to take much time, because in the next session, we'll be doing the motion under constant gravity. Okay, very important concept. And afterwards, we'll proceed with this projectile motion, circular motion, and your kinematics is going to be over. Vector is a big portion. Okay. Okay. So, guys, I hope that this is clear to everyone. So, with this, thank you very much. Have a good day. And please don't forget to subscribe, like, and share about this channel so that more students can come and watch the sessions. Okay. So, thank you very much. Have a good day.